All right, so hello once again, and today we're going to consider the network communication, which is one of the common ideas of the modern web applications. In order to do so, let's have a look at brief history of the web. It's really brief, just believe me. All right, basically, perhaps you heard the term World Wide Web. It's although started in the late 80s. The basic idea is to interlink the hypertext to share the resources which are linked by the hypertext. So we should say thanks to this man, Tim Berners-Lee, who is the best known as the inventor of the World Wide Web and stuff which he invented. Today we call the internet. The resources are transferred via the protocol, which we'll consider a bit later. So the idea was pretty simple, is to share the resources in terms of the hypertext by using the existing protocols. And really this idea is so simple and this is so popular nowadays. All right. Briefly about the HTTP. The picture on the screen is in the model, which is called Open System Interconnection, or the OSI. It's a conceptual model that gives characteristic on the communication functions of two connectivity points, for instance, between a telecommunication or a computer system. It gives the abstract description of how communication happens, or if we put it another way, how to organize the communication between 2 points, for instance, between 2 computers or 2 communication systems. It all starts from the bottom to the top. Here are some examples of representatives of each layer. And starting from the bottom, which is, for instance, cable, network devices, the whole network itself, and up to the application layer. Most of you are familiar with the application protocols, and HTTP and HTTPS are not the exception. Basically, the application, the protocols on the application layer tell us what we want to transfer and how. And the OSI mostly defines the way of communication without regard of the underlying internal structure. For instance, if you want to perform the HTTP or FTP request, you only need to possess knowledge about how to work with this or that particular protocol without knowing what TCPs, which network devices are used in order to transfer your request, and so on. Based on the OSI model, TCP IP standard appears. It's one of the implementations, and it already defines the layers based on the OSI model. For instance, the first 3 layers on the top forms the application layer for the TCP/IP standard. It's all related to our application that implements data transfer logic. As for the transport layer, also known as host-to-host, knows how to transfer data, how it happens, and it established a connection to some host. Going down, network layer, it's, to put it simply, it's a router. And in order to understand where to go, we need a physical address. In our case, it's an IP address. And the hardware, I've already mentioned cables, network devices, and so on. And the brief explanation at the bottom of the slide, TCP is mostly about the data and how it transferred, and the IP is the actual location of the system which is connected to the network. There are several standards of the HTTP, and we are going to consider each of them shortly. All right, how does the protocol, which is called HTTP, works? It's quite simple. In order to make requests, you need to know how to work with this protocol, and once you send a request, in case of a successful response, you'll get the response from the server. It's pretty much simple concept. In order to do such requests, you need to know where the server is located. Here is the detailed scheme of the URL, which also known as Uniform Resource Locator. The most common parts which are used in the URL are host, path, and query params, to my mind, because fragments mostly used in the client side, because if I'm not mistaken, most of the backend frameworks are not able to handle the URL fragments. All right, we know the URL address, but what the system is responsible for mapping these URL addresses to the real addresses of the computer. If you know the actual address of your computer is the IP address. So in order to answer the question, let's consider such term as DNS, or domain name system. If you try to run this command in your terminal, by typing the DNS name, you'll receive in the actual address, which is relative to the DNS name. For instance, if I try to copy this address and put it in the address bar, perhaps you don't see it. Okay, let's try like this. So as you see, I put the address here. If I hit enter, we see that actually google.com appears in the Google Chrome tab. And this is how it works. When the browser performs a request, by the way, when you type the DNS name, when you type in the URL on the address bar, you actually perform the usual HTTP request, and in order to resolve the actual IP address, the browser performs the DNS lookup, which takes some time, and it happens under the hood. So we won't give a deeper dive into the process. And maybe you know that the operating system has the file which is called the host. It doesn't matter on which operating system. It can be Windows, Linux, or Mac OS, whatever. So it also maps the DNS name to the actual IP address. For instance, I type here myawesomeapp.com to my local host, and if I try to resolve the app, I actually get to my local machine. All right, and how the connection appears. But before moving on, let's try to check the chat. Okay, nothing here. All right. So how the connection happens? In order to establish the connection over the TCP/IP model, we need to perform a triple handshake. And what does it mean? Before sending the actual request, we ask the server, can we perform the request with specified parameters? And in case the server answers yes, move on, we send the actual request, which is marked by the green arrow on the picture. It's better to remember such term because we'll return to it later on. So basically, before the HTTP 1.1, most of the HTTP connections, most of HTTP requests awaiting the hypertext in return from the server. So this. So before HTTP 1.1, the all requests were looked like this. And moving on, HTTP 1.0, and it contains more data. So we see that that's some request header appears here. And getting back to HTTP 1.1, more request header appears here. So what the brief explanation of what the request, what the HTTP headers, and if you see that under the number 1, these are the request headers which sent is implicitly by the browser, and under the number 2, these are response headers which tells the browser, for instance, does it need to cache the data which came from the server, or maybe to set some cookies or the and other extra data that needs to the browser to handle the request properly. All right, so we considered the triple handshake model. And let's see what will happen if we try to perform the request. If we use the HTTP 1.0, we see that in order to perform a new request, we have to negotiate a new connection. So as you can see at the picture, before we perform the actual GET request, we negotiate in the connection via triple handshake. And once we got a response from the server, we close the connection, and in order to perform the new one, we have to open a new connection. To solve this problem, in HTTP 1.1, the header keep alive appears, and it allows us to perform a new request without closing the existing connection. So if you see that we perform the HTTP request, now if I try to make the HTTP request simultaneously, perhaps we need the request pipelining, which is not longer supported in modern browsers in favor of HTTP 2.0. And about the differences between the HTTP 1.1 and 2.0 we'll consider later. All right, but before stopping supporting the request pipeline, we can, under the single connection, send the multiple requests and get the multiple responses as well. And here is the note about I've told recently. So a brief characteristics about the HTTP protocol. It's fully text-based. The headers you've seen before my screens and the response are all the text. Because the HTTP protocol initially designed for transferring the text, the hypertext. Because this protocol is text-based, we can call it simple. So pull protocol, what does it mean? It means that HTTP performing HTTP request is a one-side communication process. It means that the server where you perform the request is not able to pull response back if you haven't sent the HTTP request, and the server is not able to send the updates without making the request. Each new HTTP request is a stateless because each request is independent. A new request is like a new one without knowing what the previous request contains of, and scalability. It means that if you have multiple servers on your site, for instance, 5 services which run a single code, and if you put the load balancer among your servers and try to perform the HTTP request, they will send you identical response. They are independent and they work independently. By the way, this commonly used practice in order to increase the performance of your server-side application by adding a server instances and putting load balancer around it. So we've seen a brief HTTP structures with the request headers. So let's have a look at it once again. There is a listing of some request headers. Some of them are content length, refer, and so on. So I would like to mention that request headers are sent by the browser implicitly. As well as response headers are sent by the server, which sends you the response. For instance, cache control, which tells the browser the expiry of the cache if it try to store it and reuse the content encoding. The most popular encoding method is gzip, and it dramatically decreases the size of the data which is transferred via HTTP. Content type and many others. By the way, by putting X at the start of the header name, we denote that this header is set by the server itself, so it's the custom one. Okay. Many of people there is a misconception between comparison encoding and encrypting. This is not the same thing, because encoding is mostly about compressing the data and how to perform the lossless compression, and encrypting is mostly about the security. So as I told you, gzip is one of the popular content encoding method, and you can get more familiar with it via the links below. There are several HTTP methods which help with them. You can make the HTTP request not only get some information, but what if you want to create or update something? So here are a bunch of HTTP methods. The most commonly used are get, post, put, and delete. For instance, options is the very first request which browser sends to the server, and he asks a server how we can communicate with it. For example, it sends a response. The server sends a response without the body and tells the browser about supported HTTP methods, headers, and so on. Also, the server can indicate the status of each HTTP request, and the statuses are divided by the code. The first number of the code tells us what kind of the status. The most common is 200, okay, 201 created, for not found, and so on, and internal server error as well. So the common HTTP statuses, and you can get a deeper dive by visiting the link below and read about statuses of HTTP requests. Mostly the post request is performed by typing something in a form, but basically it's nowadays it handles in a bit different way. So, and we'll see it. I told a bit about cookies, but what the cookies are, it's kind of a small piece of the text data which is sent from the website and stored on the user's computer by the user's web browser, and it transfers with each request. What kind of data a cookie can store? For instance, session cookie, also known as in-memory cookie, exists only in temporary memory while the user navigates the website. When you close the tab, browsers delete session cookies when the users close the website. And persistence cookie lives for a cookie's lifespan, which is specified in the request response headers. Something like here, where it's going. I like response headers. Oh, okay. So there is no cookies here, but I saw somewhere. Here we go. No. So okay. So we'll consider the cookies later on. So the main difference between the session cookie and persistence cookie is the lifespan of the piece of the information. So how to control the cookie? One of them is accessing the property of the document and set the data manually. It's a rare case, and the most common one is getting the cookie from response. So you can manage your cookies via the browser extensions. I told that the cookies are stored on a computer. So unfortunately, I don't remember the path for the Unix systems, but okay. But it's not a good idea to to manage the cookie manually via the file system. And also we can send some piece of information via the meta tag, and it is also the quite rare case. The most common one is to grab the cookies from the response, which are sent from the server. The only HTTP had the access to the cookie. So let's have a look. And here are some explanations how to set cookie and yeah, and what are restrictions for the access. So here are the full information about the cookies. All right. So perhaps you've seen the term, which is asynchronous JavaScript and HTML. Let's have a look at the scheme here. Earlier, most of the web applications were multi-page. It means that in order to access some resource, you perform the request to the server and get the entire hypertext to be rendered on the client side. And with each request, you have to reload the entire page. With the help of the AJAX, which is asynchronous request, you don't have to reload the page. You just perform the request in the background. And this approach is mostly used in the single page applications. There are some drawbacks of using AJAX. Some of them are the browser can disable the support, but it's, to my mind, it's not quite possible. But if we are using the old browser, okay. Of course, this is the headache for most of the developers. In a few words, CORS is the cross-origin resource sharing. It's a restrictive mechanism that tells the browser from which origin you can access some API, what methods, headers are supported by the API. And it's mostly set with the help of access control headers. And we'll get a deeper dive in a while. All right, before we move on to the real demo, I'd like to see the chat. Okay. I don't see your questions right now, but you can ask it at any time. And now let's have a look at the examples of the simple HTTP requests. So here is an example of XHR. Actually, it's an old-fashioned way of performing the request. In order to do so, we need to specify the URL of the request, the methods of it, and to perform send action. And put some listeners here. Could you make the phone bigger? Of course. Okay, that's much better. Okay, you're welcome. All right, so in order to perform the request, we specify the URL and performing the action. Some listeners here, for instance, on Node, which tracks the progress of our request. On progress. On load is the listener which triggers at the end of a request, and at the time the callback is called, we can see whether the request was successful or not. Frankly speaking, I haven't seen the tracking progress on the applications because in the majority of cases you don't really care about the progress of your request. In most cases you just send and waiting for response, and in case of unknown error we'll also handle it. And let's see how does it work. But before we do it, I would like to uncomment the script tag. Okay. So it triggers the first alert, which is on progress. So we received some amount of data and we got it. So let's do it another way. I would like to do like this. In order to show you the Chrome DevTools from the network perspective. Yeah, and if we look deeply at the list of the requests, we see that firstly we access our our page, loaded the script, and performed the actual Ajax request. And mostly it's by extensions, so don't pay attention to it. What we got in the response, we see that it's actually ordinary JSON. In order to get the object from it, there are several ways to do it. One of them is to set a response type and get the JSON already parsed. So let's see how does it work. Okay. If you might have noticed, the alert says that I received undefined bytes. It's because the browser cached my request and got the object here. So let's have a deeper look at the headers. So let's start from the request. So these are specified by the browser, and the interesting header here, accept language. It depends on the language that you set within the browser settings. If the API designed for multiple languages, and if you change it in your browser settings, you'll see the website on your I don't know, native language if it supports without setting it explicitly. And a couple of information here, and response header also contains a bunch of information here. All right. And of course, instead of setting the response type explicitly, you also have possibility to do it manually, like JSON stringify, like this. But maybe it's better to set the response time here. All right. So, and what if we want to set some request headers? For example, the API is accessible only if we specify the access token, or after we provide some additional information, so we also can set the custom headers in such way. And if we perform the new request, we'll see these headers in our DevTools. Yeah, as you can see, there are actually two requests within the same URL, as I told. The first of them is options, which asks the server which methods headers it support, and here we got the actual result. Here we go, and here's our custom header set here, as well as the content type header here. Okay, and what if you want to post some data? The main difference between the methods like get, delete, head options and the post put is the request body. In case of get, I don't pass anything here. So in order to perform request with the request body, let's pass some data in the form of the object with arbitrary attributes and try to make the request. And the echo told us that here is our data we passed as the request body. And also here in DevTools, you can see the request payload we passed within the XHR. All right, but I told that this is the old-fashioned way of making requests, where you can see it in some sort of legacy projects or in the old documentation. The more convenient way to do so is via fetch. So let's have a look at the fetch API. We'll do it in a form of live coding because it's quite simple. And so let's try to do it. The only thing I need here is the URL. In order to perform test requests, I use the Postman echo, but there is a problem with the course access control. And maybe if you perform the tasks with the HTTP request and face the problem with the course, let me show you. Like this. Oh, no, here. All right. Yeah, we got the request failed. And the reason is the request from origin has been blocked by course policy. So you can easily bypass the course restrictions by putting the link, which is course anywhere. If we refer to it, it's kind of the third-party application which is plays a role of proxy, and it is the easiest way to bypass the course restrictions in case you work with external API by unknown developers. But in production cases, it's important to configure the course headers properly. All right, so let's try to use the fetch API here. And I need the URL. As you might have noticed, I also passed some sort of query params here. By the way, what is a query parameters in the URL. It's a set of parameters that basically attached at the end of the URL, and they help to define specific content that you are looking for. For example, making the search request via Google, you'll see a bunch of query params here. For instance, under the param queue, it says that we were looking for HTTP. Let's try some random text, and we'll see it on the input field of the on the top. All right. So let's try to use fetch API. It's quite simple. There is a global function which is called fetch, and we'll try just to use it and see what happens next. Let's try to log first and see the result. Yeah, the log call, the console log tell us that this actually the object which is called promise, and it is in the pending state. The network tab on the DevTools tells us that the request was performed, but we haven't extracted the result of this request. In order to deal with the asynchronous operations in JavaScript, I need to use the special global object which is called promise. And if you highlight the fetch function, it tells that it returns promise. What basically promise is? This is the object which holds the state. These are pending, fulfilled, and rejected. So while the promise is in the pending state, it does nothing. Fulfilled is or successful or failed. Maybe it will be much better for understanding. So when the promise is successful, we can extract the data from it by accessing the property then. Let's try to do this. Then accept the callback, which will be called on the fulfilled state. Let's try to do this. But if we try to do this in this way, we'll get and where the log. Okay. So we got this special object with the full information about the response. But the only thing we need from the subject is the actual response, which is located here, the response with this data. And in order to extract it in a proper way, need to do another need to parse this response and grab the parse JSON data. Let's do. Okay. So this method also returns promise. That's really interesting. All right. Let's try to put it another way. As you might have noticed, I put several. The promise supports property chaining, and I'll get into the details later, but let's see the actual response. Yeah, here we go. And the response is printed on our console. And what if the response failed? For instance, we've seen the course error, so let's try to do it. First, we'll see the actual error, the request error in the console and encode in promise. So the promise allows us to handle the errors by the property catch. So let's see. Yeah, and here we called the type error. So I told that the promise supports the property chaining. I mean that I can use as many properties as I want. I'd like to consider another case. What if I need to extract exact data from my response? But no. Okay, let's put the course anywhere back to our URL in order to make it successful. And as you see, the object contains a lot of properties, but for instance, I need only arcs to be passed forward. So what I'm gonna do, I'll return the property arcs here and try to log the response. And I see the part of the whole response. Let's check. Yeah, so the object arcs contains of two properties. Yeah, the console printed two properties as well. So this kind of chaining allows us to perform manipulations with our data in such a way, and also we can perform partial calculations. Why not? So as you might have noticed, in the callback, which is passed inside of then, can return both some sort of data and the promise as well. So let's try to return another promise. Let's see. Let's try to create our custom promise. Just accept the function with two callbacks. Reject. Set timeout. Yeah, let's try to resolve with some data. Let's try to do it here. So we'll resolve in, let's say, in 5 seconds and try to log it. So let's see what happened. So the request was received, but there is no data in console. And here we go. It happens because the second then, no, the third then waits when the promise in the second then will be resolved, and only then the third callback will be invoked. And what if we, instead of resolving the promise, call reject in 5 seconds? And in order to identify the callbacks, I'll do this in that way. Access. Five seconds, and an error occurred. And as you can see, let's see it here. Yeah, an error occurred, and it means that the third then was ignored because of the error was thrown within the promise. And also, if you try to throw the arbitrary error via throw error, the cache block also will be invoked instead of them. Okay, so as you can see, the fetch API is pretty simple. And what if we want to pass the extra data, like the method of the request, maybe some custom headers? To do it, there is a second optional parameter with the object, where we can pass the only necessary options. For instance, method, let's say post, and so define some headers. Object, I'll copy the headers from here. Like this. So we define a header, and if you're making a request, the post request, it's also a good idea to define the body of the request. And we should define content type as well. Let's grab it from here. Like this. Okay, let's try to perform the request, but try to post here. Okay, let's see. Oh, see that is promise here. Oh, arcs. Okay. Let's comment this down in order to see the request immediately. Yes, success request, and the request body is already passed here as expected. I see the question mark in the chat. What do you mean? All right. So this is it for the simple request. Let's move further with another concepts. But maybe before I move on, let's discuss your questions if you have any. Yeah, it happens, I believe. I've mentioned about HTTP2. I would like to consider the the key features and main differences between this and the HTTP 1.1. The main restriction and the main problem of the HTTP 1.1 is that it allows to perform only 6 requests simultaneously. In order to ensure this, let's have a look at the example here. And so let's update HTTP 1.0, for example. And if you look at the waterfall, which is located right here, while scrolling to the bottom and seeing the status of the request, we see that most of the time it's waiting while the previous requests were finished. And we wasted so much time while loading the picture by each tile. As you can see, it's not a whole picture. That's designed for a test. Okay, let's see what happened with HTTP 1.1. It's not the result I expected, and it's a real it's a 1 second delay. I'm sorry. Okay, so the main as you can see here, it's about 6 bars here, and most of the requests are doing nothing except waiting while the previous is finished. Let's try the HTTP2. And as you can see, the picture loads much faster. Here, the only waiting time is for the main request, which define the tile to be loaded, and the load time is dramatically reduced. Okay. And another problem with HTTP1 is that the only thing which is encoded is the payload, but every metadata, which are the headers are the representatives of the metadata, are not encoded. And there are some other key differences and key features of HTTP2. So what enables the HTTP2 to perform so many requests simultaneously? So if we remember the shaking connection, it's any HTTP request is performed under the TCP protocol. In order to solve the problem with the number of simultaneous requests, HTTP2 performs all the requests under one and the same connection, and it allows us to parallel all the requests. So the multiplex request allows us to work with a stream of data. And it brings the possibility to perform push responses into the client application. If we see the picture here, all the data is divided by the streams. These streams don't block each other, and the client and server can send and receive the data simultaneously. And as the data is binary, instead of text data is represented by the binary data, the HTTP structure is divided by the frames, and it's and the request is more simple to transfer. And here is the statistics which browsers support the HTTP2 standard. We won't pay much attention to it. And here are some useful links to learn the concepts of HTTP2. The slides. So what HTTPS is? It is an extension of the hypertext transfer protocol, and it is used for secure communication between the server and the client. In order to provide the security, it uses the encrypted protocol, which is called TLS. So to achieve this result, it adds a new layer to the TCP/IP model. As I mentioned, that once you perform the HTTP request, it moves down to the bottom through the layers in order to transfer the data. And the TLS is the extra security layer. So it's mostly works under the certificates. For instance, in order to ensure that the request, let's say with the sensitive data, you perform, come to the server, the server needs to identify himself. And for identification, the SSL certificates are used. And before to make a real request, it checks whether the certificate is valid. All the checks are performed via the certification center. And maybe that's all you need to know about the HTTPS. The only thing to pay attention to is that the HTTPS should be used by default, because most of applications work with sensitive data like user credentials, banking financial information, bank information, and so on. And if you'd like to order the certificate to your server, so you can do it here. So speaking about CORS, which is really annoying, I know. But in order to get better understanding of what CORS is, I'd suggest you to pay attention to the links here. I told that the CORS policy sets restrictions on origin, but it also restricts the supported methods which headers is accept, and how long the response to a preload request can be cached as well. So REST, or representational state transfer. What is this, and why is it important to know what the REST is? Maybe I've heard that the API can be RESTful, but what does it mean? So to put it simply, the API counts RESTful if it follows the principles that we're going to consider. These principles are client-server architecture. It's explicit separation of client and server. server and client applications are the separate ones. So the there is no state on the server side while performing the request. So the API shouldn't store client state, and each request from any client contains all the information which is necessary to serve the request. And all the session data is stored on the client side. In order to transfer the state between two services, need to use another storage such as database to maintain and persist the state for a period and let's say allow the authentication. But the main idea is that all requests are handled separately, and the server doesn't care about the payload of the previous request. He works with the new one independently. Cacheability. It's kind of obvious because it enables us to cache the data, and each of the points in our infrastructure need to know that data wasn't changed and we can grab it from cache. This principle tells us that a client cannot tell whether it's connected directly to the end server or to moving forward to another microservice. And the client doesn't care about the server-side structures, and all it needs to know is how to perform a request, know the URL, which headers it accepts, and this is it. Code on demand. This is the optional principle, and here's the explanation, which is, I think, is enough. But honestly, I haven't seen this principle in action yet. But in the world of Java, maybe it's a common case, but not in JavaScript. Uniform interface. It's mostly about resource manipulation through representations. It simplifies and decouples the architecture that enables each part to evolve independently. Yeah, some sort of mistake here. Yes. Yes, not a, yeah. Everything is okay. So in order to achieve the principle, each message in the request should include enough information to describe the process specified by the headers. And here are some other examples of the hypermedia. But last and not least about the REST, and most important is the REST is not a separate protocol or a standard or a model. It's mostly about the way of implementing backend APIs, and actually it's the architectural style which most of the developers try to follow. All right, before we move on, let's check the chat. Okay, nothing here. And we can move on. So the last thing I would like to cover is the WebSocket. So what's the purpose of using WebSocket and what problem does it solve? And as you might have noticed, the problem is the real-time communication. As I told, an ordinary HTTP request is pull-based, so it's mostly about one-side communication. I told that HTTP2 allows push requests, and it allows to for the server to push some updates. It requires the connection to be alive, not via the header. Once the connection is open, the server is able to push the updates to the client. But if there are no updates, the server closes the connection and you have to open the new one. So in this case, WebSocket comes to the rescue. In modern web applications, there are a lot of use cases of real-time communications, such as the chats, any real-time notification, the bank information, games, and so on. So this protocol, which is, by the way, the protocol which is located on the application layer of the OSI model, it provides the continuous connection between the client and the server, so both client and server can exchange the information at any time. Okay, let's check here. Okay. So as the protocol is full duplex, it allows to send the updates and exchange data in both ways. And as it doesn't require to pass extra data like headers, cookies, on the only thing that WebSocket is care about is opening the connection once and transferring some sort of data. It's actually the request body. So the WebSocket is quite faster than the ordinary HTTP request. And the working with the socket, this looks like this. We create the socket on the sub URL and pay attention that we work with the WebSocket protocol. And there are some handlers. For instance, once we open the connection, just created it with the open callback called, invoked. Once we receive the updates from the backend, the on message callback invoked. In case of some errors, this handler, and in case we close the connection to perform some sort of cleanup, the onClose function is called. From the comments here, you can see that we can send not only strings but some binary data like blob or array buffer. But why do we need the binary data? But before I answer the question, let's see the example of usage of the WebSocket. So we open the connection. Once the connection is opened, we notify the client. We send the message via WebSocket to the backend, and we receive the data back. Let's see how to work with WebSockets. I uncommented this line. Yeah, what happens here? Let's consider the WebSocket example. As you might have noticed, in the example I put WS, and the example on my IDE is WSS. It means that it's like an HTTPS, which means secure. All right, so what steps should we perform in order to get started with the WebSocket? First, we just open it by creating the object WebSocket, which accepts the URL. Once the connection is established, we call onOpen, which prints the connected to the screen like this. Let's make it bigger. And once the socket is opened, we send another message. So let's see what to send, which actions it performs. Write to screen. This creates a new element in DOM, and it invokes the send method in order to send the message. Afterwards, we receive the response from the backend via WebSocket and print the text in blue. Let's see what happens on message. Yeah, we're writing the message which we received from the socket and closing the connection. This is in our case. And once we close the connection, print the message here, disconnected. Let's try to perform multiple messages. Send. I did the loops in quite unusual way, but okay. Let's try to send several messages. Oh, I'd like to do this in such a way. Oh yeah, it happens because I disconnect the WebSocket. So we won't close the connection. Let's see what happens. Yeah, here we go. We received all the 3 messages because I use the test WebSocket, which actually returned the messages back to the client in the exact way. Okay, and this is the basic usage of WebSocket. And another interesting thing is that WebSocket supports something that as at event listener instead of accessing properties directly. And without on, like in plain JavaScript. And I can, instead of setting the property on open, just add the listener. Just like you do while working with DOM. And nothing changed from the client perspective. On open, callback works correctly. And the same thing with close, message, and error. We haven't tested it. Close. on message and on error. Let's try to block the request and test the on error callback. Okay, so it seems that the blocking request doesn't work for the WebSockets, but okay, let's do it another way. Or even let's make a mistake in the URL. Yeah, and error actually works. Okay. All right, so we've considered the basic usage of the WebSocket, and I told you about the binary data. Why do we actually need the binary data while working with the WebSocket? It enables to do a couple of things like working with WebGL, transferring files, and maybe receiving some special data to draw it on canvas, and many other cases. So instead of an ordinary string, you can pass the binary data. And what exactly data you can pass? There are several browser abstractions that allow working with binary data, and some of them are on the slide. And in order to use the to pass the binary data to the WebSocket, we need to create one of the instances I've mentioned before and set the property binary type to one of the supported. In our case, this is the array buffer. All right, so this is it from my side for today's lecture, and I put some useful links to be acquainted with, and I'm ready for your questions, if any. So maybe you want to ask me something? Do you have any details regarding your new task? Unfortunately, I don't possess the information, and if I'm not mistaken, you'll be dealing with the weather task. But well, I am not able to answer your question because yeah, it's weather task. If I'm not mistaken, the task is the same as in the main groups in the ERA school. It's mostly about working with external APIs with asynchronous data, and you'll work with a lot of external APIs. This is a brief explanation because maybe let's try to well anyway, the task will be added to RS app today, and you'll see it. Probably some API fetch and render, then it's processed. let's do this not in this way in order to see the chat with you. Perhaps I don't quite understand your idea about the supported Code.js interview. It's on the schedule for today. Well, I believe you should ask these questions to the person who is responsible for it, because I don't actually know what happens on this course, and I just come here to speak with you, to tell something. Some recommendation about new task. All the useful links will be added to the task description. Don't worry, and also I'll share the slides and source code I've written recently. Share some HTTP real life examples if you have one in Discord. Do you mean by HTTP real example some sort of external API? You know, you'll get enough practice with the upcoming task while working with HTTP, I believe. But if I had another HTTP example, if you mean the external API by some HTTP example, I don't possess for now, because the only example I found is just echo, because I want I don't want to get to register somewhere to get API token. That's not my way. All right. Any other questions? I accept any sort of questions. All right. In case of no questions, you can still leave it on the Discord. If you want me to answer your question personally, you can tag my name on Discord, like here. All right. In this case, thanks you for your attention, and have a nice evening. Good luck.